Okay, so this is our feature presentation, tour of Bitcoin D. So this is a little bit of a follow-up from the one I did 2 months ago. I did a Block Explorer presentation. If you're watching the video and you haven't seen that one, it might be worth going back 2 months to that one first as sort of a preamble. If not, don't worry too much. Maybe you can watch it later if you're interested. Yeah, it would just make a bit sense to watch that one first. Yeah, I just wanted to talk a little bit about the software that defines Bitcoin and also the Bitcoin core project. I have a little bit of experience with it. Wanted to kind of share a few thoughts. And then also just showing the software if you haven't run it before or you ran it once and didn't understand it. Maybe this will kind of help to see it a little bit through my eyes. Okay, so first of all, what is Bitcoin D? So kind of the first thing that maybe comes to mind is sort of it's a wallet, but it's actually a heck of a lot more than a wallet. It's actually this very intense thing where it's like a CLI, it's a daemon, it's sort of a Unix program. It doesn't necessarily have a GUI. The GUI is kind of incidental, which I'll get into. Really, it is a CLI thing. It's a networking thing. So if you're not really used to that, if you're not a hardcore software person, it might be really hard to classify what this software actually is. So another thing that it might be is it a blockchain database? It kind of is, but it's kind of not, and that's another weird thing about it. The blockchain kind of gets equivocated with a database. And that's not strictly true. It's a database, but really only for the addresses that you're interested in. The rest of the data just gets validated. It doesn't really track the data other than the UTXO set's kind of the minimum that it needs to validate blocks. Is it mining software? Not really. That was kind of the first thing that they took out. Is of course, once Bitcoin started, mining was very competitive fairly quickly. And so just people wrote their own mining software. So Bitcoin kind of lost interest in trying to make mining software pretty rapidly. So it's not mining software. You can't mine on your CPU anymore. That's basically a useless thing to do. But another thing that you kind of got to understand of what Bitcoin D is it's really the networking code. And this is almost as important as the consensus code. Is it defines how transactions and blocks propagate through the network. There's some caveats. There's some other software that does similar things. But to maintain this decentralization property, it kind of defines what it believes is the right implementation to network Bitcoin in the peer-to-peer network. But if I were to kind of boil it down, the reason why I run Bitcoin D and use it for software development is it's the reference implementation. This is the software. There's no like piece of paper that defines what Bitcoin is. It's really the software that defines what Bitcoin is. So we call that the reference implementation. Every protocol generally has a reference implementation that kind of you can at least use it as a way to check your software against. So if you're trying to do something in the protocol, it's probably going to interface with the reference, or if not, you can at least use it as a sanity check. So it's that. That's what Bitcoin D is to me. But as a developer, and I'm building Sparkshot with Dean, we have to interface with Bitcoin. We're transacting money. So what we do is we use the RPC interface into Bitcoin D to do that. So it basically, as Bitcoin is defined as programmable money, you program it through the RPC interface. So that's those 2 points are kind of the most important in my mind, but the rest of it is fairly important as well. And there's actually quite a lot to talk about. This is by no means a comprehensive talk. So why would you run this software? So to me, the kind of the most important thing is if nobody ran the software, we wouldn't have Bitcoin. It's kind of this weird logical thing, kind of like voting. If nobody votes, is there even a democracy to speak of? It's sort of one of those things. If people like you don't run nodes and they don't enforce the rules of the network basically doesn't exist. Or it gets concentrated, the power of the network gets concentrated in the hands of the few. So just by running the node, you're kind of participating in decentralization. As if every person in every town and every city and every block ran a node, you could definitively say that the entire network is decentralized around the world. So there's sort of a participation thing, which is also a really strange way to run, to imagine software, I'd say. It's kind of why this software is unique. As covered in the Block Explorer presentation, another reason why you might want to run a node is to watch your Bitcoin balances in a private way. You don't have to ask a Block Explorer or some other server what your balances are. You can get those locally on your own private machine, do that computation yourself to figure out how much money you have. And I have a little bit of an example of that. Another reason is, like a lot of wallets you might use, hardware wallets and all that, they're written by some other team, some other commercial interest type thing. Whereas the Bitcoin D, you can think of it as it's the best software. It's open source, it's got the maximum amount of scrutiny. It's a very, very good wallet. It's really hard to, on the qualities that matter, it's very unlikely that a different project is going to have better Bitcoin software. I mean, depending on what they're doing, if they have some special purpose thing that Bitcoin doesn't do. But yeah, if you want to run the best software, this is more or less it. And the bottom two, these are other reasons why I run it. I develop with Bitcoin, so it's just a necessity. And then, yeah, I've just been constantly learning about Bitcoin. There's a lot to learn, and you get a lot of really good first-hand experience interacting with the software and kind of learning the minds of the developers just through, learning how to use the software and kind of getting first-hand experience. Okay, so let's talk about Bitcoin Core. So Bitcoin Core is the open source software team that develops Bitcoin. So if you're familiar with open source, there's generally no commercial interest behind it. It's just volunteers around the world that they like software so much that they want to develop software and they're okay not getting paid for it. Or they, perhaps a company sponsors them, so a Bitcoin company would, they have interest in keeping the network healthy, so they just want to pay a guy to, keep tabs and contribute to the project, just to keep the project healthy. So really, there's at this point, there's been hundreds of developers. This is sort of the listing of kind of the top. If you're measuring commits, that's not really a great measure, but more or less, these are kind of some of the top primary guys. You've probably heard their name, like Lute Jr. and Jonas Schnelli and Blue Matt and Vladimir and Peter Willa. And there's a bunch of others. There's more or less about 20 or 30 really hardcore developers, and then there's a long tail of hundreds more. So Satoshi obviously started the project, but yeah, as of now, Vladimir, a guy named Vladimir, is the lead maintainer. You can see him at the top of the list. But yeah, that really doesn't matter. That's not. It's not that he's like the king of the project. He's just kind of there to do the grunt work to manage the project. So yeah, I believe he gets paid by MIT. He's got some arrangement with MIT for them to pay his salary, and he just kind of does what he wants, maintaining Bitcoin. And yeah, roles are organic. There's not somebody nominated as a certain job title other than really like Vladimir. Roles are just kind of organic, like people do what they're good at. People just kind of self-organize to develop the software. This is a very strict culture of really good software development. This is world-class software development. And professional, what I mean by that is code gets written in a very clean way, and people aren't putting their egos into it. If you write code, you got to expect it to be criticized, and that's really for code to get merged into the main branch. Like dozens of these people have to do a careful review of the code to kind of make sure it's bug-free. So one of the things that I think makes Bitcoin Core work is it's the culture. And it's really established by people like Vladimir and people like Peter Willa and a bunch of these other people. This, like I worked as a professional software developer in a corporation, we had a very good culture when it came to code quality. This is a couple tiers above that. Stuff that you only find in some of the, like stuff like the Linux kernel and, the glibc libraries and that kind of thing. Some of those like, super important projects, everybody uses stuff like, the GCC compiler and stuff like that. Kind of one of those elite open source projects. They have a very similar culture, perhaps even exceeding a lot of those projects. So it's a very good team. One of the lessons is these guys don't need more code. That's another unique thing about Bitcoin. A project like Linux, there's always like drivers to write. There's always like file system experimentation. There's always lots of code that they need. And the size of the code base of something like Linux is constantly growing. Here in Bitcoin, they do not need lots of code. They need very little code. They need the correct code. They need people to write it absolutely perfect. So if you're to just show up and start like submitting pull requests, they'd probably get ignored. Is like every line of code is actually work in the long run that these people have to do to maintain that, to make sure it's bug free. So, and these guys are already like super talented programmers. They don't need help. The help that they need is people to check over the existing work to make sure it is correct, that's been tested. After all, there's $100 billion plus of people's money that's at stake. So a bug in this code is very, very expensive. And there's a scarce amount of quality review time. So yeah, they don't need code, they need reviews. So that's kind of fundamental, and all these people get it, and that's part of the very good culture. So just a basic rundown of the software. I mean, it's written in C++. So it's a compiled language. C++ has good sides and bad sides to it. I'm not generally a fan, but that's what it's written in. It's still a fairly decent language by modern standards. Satoshi started the project. He was pretty clearly not a super professional programmer. He was clearly a very smart guy, like smarter than all of us in this room to invent Bitcoin. But he wasn't a practiced programmer. It was pretty clear that like he had probably coded once a couple, in his youth or whatever. And so he's like, okay, I got to build this Bitcoin thing. Let me like write some C++. And it had this very amateur smell at first when it first came together. And yeah, he didn't really think a lot about architecture. It was a very, very much an experiment. So that was more or less the code base from inception to like probably sometime in 2011 when Bitcoin kind of got more popular and it picked up all these other developers. So kind of handing off from Satoshi, some pretty good strides have been taken in just making the code base a lot better. But back to this, bugs are very expensive point is refactoring, reworking this code is very, very scary. That's when bugs happen. So there's a lot of reluctance to make large changes. So there's kind of a little bit of living with bad architecture for the time being. It's not the worst thing in the world that the code's maybe a bit clunky. Yeah, they just want to avoid refactoring, avoid too much feature creep, and keep it very, 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 very simple. We don't want people to lose their money, so we got to keep the bugs out first, number one. So keep it simple, stupid. And just as a kind of philosophical point, simple is not easy. Simple sometimes is the opposite of easy. Easy is like, oh, here's a great GUI. It does lots of bells and whistles. That's all that. That makes it easy for people, but it's not simple. Simple kind of is simple software that helps you build other software. It's a little bit different taste in engineering. So a lot of people don't necessarily understand that, and it's kind of a core point of the uniqueness of this software. So there's a bunch of components. So out of that monolithic design, several things have kind of been extracted out. One of them, which is the wallet and the GUI. So the GUI is entirely separate from the rest of the code, the Bitcoin D daemon. So initially Satoshi kind of put those all together, but those got extracted apart. as did the cryptography library, the libsecp256k1. That got extracted out. That's a very important library for making sure the signatures work. If they don't work, that's a big problem for Bitcoin. Libconsensus is another big one. From what I understand, it hasn't been perfectly extracted, but you can basically get that as a separate library if you want to use it for your software project. You don't want all of Bitcoin, you just want like the consensus part. You can link to libconsensus, and that's something that the project provides. And yeah, there's a bunch of other miscellaneous things, including the networking code, which I mentioned is extremely important. Okay, so just because I had this opportunity to speak, I have a little bit of personal history with this development team. So I actually, if you go look back in the Git source code, you'll find one commit with my name on it. So I've spent a bit of time. This is me moonlighting from my day job, just tinkering with running the code, trying to understand it. And there's a couple things I bumped into that I just decided, hey, it's an open source project. Why don't I just go fix it? So I did that. So I've got one commit under my name, and I've got a couple more under a pseudonym. That was really only like about a 4 or 5 month stretch where I was occasionally tinkering around with it. But during that time, I got a lot of personal one-on-one experience with this set of people. I got to really understand how they think. And probably in some chat logs you can find embarrassing discussions where I'm talking to Peter Willa and being an idiot. And that just kind of what my takeaway from all that is I just learned that this is in very good hands. I also learned something about myself, is that while I am a software developer by training and trade and by career, I probably don't ultimately have the right temperament to work in this environment. This takes a very specific, thoughtful personality that's okay with going slow. That's not necessarily me. I like to write code. I write code every day. I write lots of it. I always have. It's like just a part of my day, part of my existence is writing code. So on this point, they don't need more code. Basically, they have no use for someone like me. I'm just in their way. And that's kind of something I learned just trying to get started in that, is that perhaps my role is elsewhere in the ecosystem, which I think I've found, working on application code with Dean. We're still doing Bitcoin, but we're writing our own application. So a lot of people think, oh, I should work on Bitcoin, therefore I should go do some work on Bitcoin Core. I'd say no. If you're not doing that already, you probably don't need to be doing that. They don't need more people, they need the right kind of person. And they've absolutely got a pretty good critical mass of people that are able to get stuff done. What Bitcoin needs is everything else. Better functioning wallets, stuff like the Lightning Network, stuff like side chains, perhaps application code, stuff like what Bitcoin Solutions is doing with ATMs and bill payments and all these other things. So takeaway, Bitcoin Core is in good hands. You probably don't need to be involved, but it's there for you to learn from. Okay, so wanted to demo the software. So Bitcoin is free software. It's open source. If you're not familiar with these terms, it's free as in speech and free as in beer. That's sort of because free is kind of an ambiguous word. Free as in speech is in like you can't stop anybody from running it. It's like nobody's gonna stop you from expressing yourself by using this software. And whereas something like Microsoft Windows or whatever wants to like sell you a license and be very restrictive, right? It's free software as in speech. It also doesn't cost anything, so it's free as in beer, free beer. Everybody likes free beer. It uses the MIT license, which is a fairly popular open source license. GPL version 2 is another really popular one. If you understand the differences, MIT is probably more suited for what Bitcoin is, whereas GPL kind of has some weird quirks that aren't ideal. But yeah, more or less, it's free. It's there for you to grab. So if you want to run the software, there's really 3 options right now. Number 1 is what we're going to do. We're just going to download the binaries and we're going to verify them. The reason you verify them is you want to make sure that you're getting the binary shipped by the Bitcoin Core project. Somebody who's trying to steal your money might intercept your download request and give you bad software that steals your money. That's a theoretical possibility, so that's why you verify it. So that's kind of the first most popular way of running the software. Number two is you can compile it yourself. You can go on GitHub, you can get the source code. If you go through the process, you can compile your own binary. That's what you'd be doing if you're developing. That's what I've done, although it takes some time, so it's kind of a pain if you're not spending the time developing. A lot more popular recently is you buy like a ready-made hardware node project or product. So like there's these things you can buy. They have maybe a Raspberry Pi. I don't even know what the brand names. There's like Nautilus and Casa and all these other things. So you can do that and you can run a node. Perhaps it's not the ideal way to learn about Bitcoin because you're basically just buying somebody else doing it for you. So really number one and number two are good for learning. I mean, you can still learn by running it in a ready-made product, but it's not as fun in my opinion. Okay, so, oops. Okay, so I'm just going to hop into the demo of actually downloading and running the software. Okay, so this is the GitHub page. This is the main page, github.com/bitcoin/bitcoin. So this is where all the core development happens. So you can click on these tabs, and here's some bugs that have been filed, and there's discussion threads of what people think and what they're thinking about. So you can kind of creep on this to kind of learn who these people are and kind of what they think and kind of what work they do during the day. Pull requests, here's a bunch. There's actually other projects that are part of the Bitcoin. Actually, I don't have it set up right now, but yeah, there's a couple different components that are done in other repositories that have similar things, but the main one is here. So this is code that's been written that has not yet been merged. But yeah, in the main line, if you go to just the main page, for some reason the internet's slow. Yeah, you can look. So this is the master version. This is like the up-to-date development branch, but you can find an old version of like 0.8 and check out that software and browse around. But what they do, so if you're just looking to run Bitcoin, you don't need to worry about all this unless if you're compiling. So they put the link. This is where you download Bitcoin, which again is slow for some reason, or I'm just not clicking properly. Yeah, okay. So this is the Bitcoin Core main download page. So I'm running Linux, so it detected that this is the version that I should run, which is the x86-64 Linux GNU.tar.gzip. So what I'm going to do, I'm going to just, in the command line, I'm just going to take that link, and this is just a command line downloader. So that was pretty quick to download. That was all of 31 megabytes. So what that is, that's an archive file that has the binaries in it. However, just getting the software isn't sufficient. As I mentioned, you're supposed to verify it. So you get this other file, which I'll explain in a second. You get this SHA-256sums.asc. So we'll take a look at that. So they don't really explain that here. You actually have to go down to get the instructions. But yeah, they kind of just make the, I guess you need somebody like me to explain this at least the first time. So what this file is, this is the SHA-256 checksums of all the files that they have for download. So I downloaded this one. Oh, again, I'm having some button problems. Okay, yeah, so this is the SHA-256 sum, and you'll notice that this is also a PGP signature, that this message is signed with there's a public key in there. So basically this is a cryptographic endorsement of these values. So if you go up here, it says these are the release signing keys. So this is a PGP, what they call a fingerprint. This is a fingerprint of the key that's used to sign those values. And I'll go into that in a moment. But 256 sum. So first of all, like I can just run on my own on my computer. I can run the SHA-256 sum utility, and I can checksum this file that got downloaded, and it gives me that value, which was 600D. So I can just do a visual check that yes, that does indeed match that. So that's a basic check, but what I want to show is just like kind of the official way how to do this. So it gives you this command, which is using the same exact utility, but you're giving it this ASC file that I downloaded as the thing to check. So if you run that, it tells you, yeah, it found this file, which was referenced in that file, and it said, hey, that one is okay, and then it didn't know what to do with the signature, which is fine. So we figured out the first step. We figured out that this does indeed match the SHA-256 sum that they said, but we need to make sure that it was signed by the Bitcoin Core project. So you see in this command, there's this value that starts with 1 EA or 01 EA blah blah blah. So that's this value up here, 1 EA5. So what this is doing is it's setting up GPG to grab this key. I actually already grabbed it, so it complained that I already had it. But it imported this key, which is known, it belongs to a guy named Vladimir, who's the Bitcoin Core binary release signing key. So this laptop now has the certificate of belonging to Vladimir. So that the final step is to check that this file is indeed signed by that key. Oh no, what happened? Gave me a warning. So first of all, it said it was a good signature. That's actually the important part. So this validated that this was in fact a good signature from a guy named Vladimir. However, who the heck is Vladimir? So this is kind of a nuance of PGP. So there's this known value, but how do you know that some elaborate hacker didn't fake this entire web page and produce their own key? Then they just used the name Vladimir. How do you know that this fully validating signature doesn't belong to somebody who is not Vladimir? So actually the answer to this is complicated. So you have to go fly to Europe. I believe Vladimir lives in the Netherlands, perhaps Belgium, I'm not exactly sure, one of those two countries. So you have to go to fly to the Netherlands. You have to sit down with coffee with Vladimir, and you have to say, hey, is this your key? And he'll say yes, and you'll say bullshit. I don't know you, never met you. Prove to me that's your key. And so what you'd do is you'd generate a message maybe off the top of your head, and maybe you'd write a poem on the spot, and you say, hey, Vladimir, if this is your key, how about you sign this message for me to prove to me that you do in fact control that key? So he would, and he'd be like, okay, well, this all seems legit, so I trust Vladimir. So I'd fly back to Canada, and I'd sit down and be like, oh yeah, that's Vladimir's key. But then how does that help you guys? So if Pavel wanted to do the same, he'd have the same problem. He can't go, not everybody can go sit down with Vladimir. But what Pavel can do is he can go sit down with me. He could say, hey, Jarret, what's your key? And I'd do the same thing. I'd sign something he came up with so Pavel would know what my key is. And I'd also sign an endorsement that, hey, this is Vladimir's key. So if Pavel trusts me and I trust Vladimir, Pavel can be, through that what we call a web of trust, he can ensure that that's authentic. So that's what you have to do if you don't develop the software and you don't compile it yourself. You're doing all this convenience, but it does have this trade-off, is that it boils down to you're trusting this key, which might not be ideal, but it's pretty secure. I think you'll agree. Basically, if Vladimir's in public or other core developers are in public, they put it on their slides. So like if I was given this presentation, I'd maybe put my PGP keys on there. such that that's like recorded in history that Jarret, who showed up for this video recording, he's telling everybody that that's his key. That's a pretty trustworthy signal that that's authentic. Oop. Okay, so that's how you validate. Okay, so what I did is I just unpacked that archive. So that's a tar.gzip. That's basically like just a zip file if you're familiar with Windows or other things. So that unpacked a directory, Bitcoin. So in here, there's a bin directory. So here's all your binaries, one of them being Bitcoin D. So that's what we came for. So let's run that. So I'm now running Bitcoin. What it has to do is just validate the file system. So, I already synced this node because, of course, I don't have time during the presentation to sync a full node. That takes several hours. It's just, I think I synced this yesterday, so it's just getting the last day's worth of blocks. You can see here, Bitcoin D is running on my system. It's taken quite a lot of CPU as it's just chugging through these blocks here. But this is all in the .bitcoin directory. That's where the blockchain lives. So if I go into like this blocks directory, I get all these .dat files that, these are more or less just database files that include the full block data that's downloaded from the network. So as blocks are downloaded, it gets added to these files on my file system. And yeah, they're just lots of binary data, which are the blocks. There's also chain state. So there's these LDB files. This is in fact the UTXO set. So that's 3.6 gigabytes, which is the UTXO set of Bitcoin. So that's very important when it comes to validating new blocks. This blocks directory I didn't check, but that's 260 gigabytes worth of data. That's all the blocks in the blockchain right now. There's a few other things, including like your wallet.dat, which is your like private keys if you're using this to transact. And yeah, a few other various things we don't have to get into, but the kind of the important thing is bitcoin.conf. So this is a configuration file where I'm setting a few options for it to run with. I didn't give it any options to start with. It just knows to look in the bitcoin.conf to kind of set the cache levels and stuff like that. And if you read through this, all these like blue lines are just commented out. It kind of gives you a bit of documentation about what this setting does if you want to change it. So that's kind of an important step if you're setting up Bitcoin Ds, to know what the options are and to set these up appropriately. By default, it makes pretty good choices. You don't necessarily have to, so that's fine. But yeah, I set it up with a few things for the RPC interface, because when I'm doing my stuff, I'm trying to write programs to talk to Bitcoin D, so I have to open it up to be listening for that stuff. So that's Bitcoin D. As it's running now, this is just a second. So there's Bitcoin CLI, and this is what I was showing a little bit of in the last presentation 2 months ago. So if I just run Bitcoin CLI with the help command, this gives me a listing of all the available commands that I can run against it. So if I give it a command like get blockchain info. Now this takes a second because it's actually spending a lot of CPU syncing a block. So sometimes, even when it first starts, it takes a little while to respond. But there it did. So it found that it's on block 599637, but it knows that the tip of the chain is like 60, 70 blocks ahead of that. So that's why it's syncing right now. And this is just some info of like what it thinks the state of the world is as far as the blockchain goes. Another one is get network info. And oh crap, it's being slow while this syncs. Yeah, just by the by, you can kind of see these blocks go by the height, and it gives you the hash of what those blocks were and a few details of it. That's just a chattery log. So get network info, this tells me that that's the version that it's advertising itself on the network. There's a few different expressions of that. And then you have a few settings, and it's connected to 8 different other nodes right now. So if you're offline, this will be 0. So this is a way you can check that you're in fact online. And then, just various other things. So in this help command, there's lots and lots and lots of commands that you can kind of tinker with. Like get memory info is another one. And if you know what that means, that's kind of not necessarily easy details, but if you know what you're looking for, you get this information. So I'd recommend playing with this if you have this running. You can do help, and you can also do help on some random command, and it'll explain what that command is, and it'll tell you what kind of options you can give to it. So that's a way, if you're reading online of different commands and what they can do, here's a way you can get similar documentation or different documentation. If you have time to slow down, you can figure out what you're doing. Or just browse these, like, that's a weird sounding command. Let's figure out what that is, and you go help. And then, so the command I want to show ties to the last presentation is list unspent. And that I went into why you'd want to run this command. So I did a help on that, which is too much to go through, so I'll just run the command. So as I covered in the last presentation, this address, this 3QLFL, this is our Forkdrop donation address. This is public info. This is for our website, Forkdrop. People have donated to this address. And in the last presentation, I showed you how to set up a node with watch only. So this is the same node that I built that off of. So I set this up to just watch this one address. This doesn't have the private keys of this particular address. It's just constantly looking for changes of that address if money's been sent in or spent. So these are all outputs that are tied to that address, and there's different amounts that people have donated. So you get this, large amount of, large blast of information of what's going on with that address. So that's something, that's a basis to start programming off of. So so here's a very brief, if you've never written Python before, don't be afraid. This is a very simple Python script. What this Python script is going to be doing, it's going to be calling the list unspent. So it's going to be getting the output that we just saw, that big long listing of output. And it's just going to parse it, and what it's going to do is going to sum up the amounts. So rather than having to look at all these values and calculate it, it's just going to do that in Python. So I run that. So in total, that address has 0.11 Bitcoin on it. And that's just an easier, more user-friendly way to figure out something about that address, is you got to write the code yourself in Python. And as I showed you, it wasn't a lot. The other presentation 2 months ago, I had a thing that also checked price. There's a little snippet of Python that checked the price of Bitcoin. You got sort of the Canadian dollar exchange rate off a web service. So you can pretty quickly see that if you had the price of Bitcoin in Canadian dollars and you had how much Bitcoin you have, you can multiply those numbers together to get like a dollar figure from a script like that. So that's a fairly simple example of how you would program Bitcoin D to do something useful that checks your balance and does all your accounting potentially in a private context. Yeah, so that's the CLI version, and briefly I'll go into QT. So this is the GUI version that you're probably more visually familiar with, Bitcoin QT. I'm running on testnet. So Bitcoin QT is like the GUI framelit. Sometimes it's called Qt, because that's a cute way to say QT. But yeah, so if you launch that, what you get is the GUI. And the thing to recognize here is the GUI is just running the same stuff in the background, like it's running Bitcoin D. And there's this layer of software that's just calling all those commands in the background. Yeah, this just has to sync because yeah, just give that a moment. Yeah, it'll be quick. So yeah, this piece of software is entirely separate from the underlying daemon. All it does is it's just a more complicated version of that script that I'm running. It's calling commands and it's like processing all that itself to kind of give you a nice user-friendly presentation. So that's a way to view this wallet, and I'm sure everybody here has more or less used a Bitcoin wallet. This isn't too unfamiliar. This is on testnet, so this is fake Bitcoin. But yeah, I was testing this out, and I sent it a bit of Bitcoin from my phone, which has some coins on it. So if I wanted to send a transaction, 0.01 BTC, I'd request a payment. I got a testnet wallet on my phone. If you just give me a second here. So this is just trying to be user-friendly. Okay, got my phone. And it doesn't like it at an angle, so I'll do it on my screen. Okay. So I can send. So I've sent it, and it should detect that. Yeah. So it detected that this transaction was received into the mempool. So yeah, all it's doing is it's just using those CLI commands and telling you something simple and easy. And so yeah, the reason why they keep this wallet in part of Bitcoin D, it's not strictly necessary, but they just want to give you an example of how they intend you to use all these things. You know, to kind of give you a friendly way. All those crazy commands, that's pretty unfriendly. But at the very least, you can kind of just trust that it all builds up to something, a presentation like this. So that's pretty cool. It's not a super fancy wallet, but it does a very good job at what it's intended to do, which is just to be sort of a reference example. Incidentally, so they also, just for convenience, they included a console. So if you go into the menu, you can show up the console, of which you can do all the same commands through here. This is kind of like a video game, like it's lots of video games. Like if you want to hack your video game, there's like a console you can get somewhere and put your like special code to load a level or something into. It's sort of the same thing. This is just giving a way to reach below. List unspent, and it actually helps you fill it out. So yeah, here I did list unspent. Now actually what I have to do is list it. So it showed 2 unspent, 1 and 2, but I just sent a transaction. So I did list unspent 0, and that 0, if you look at the documentation, that will include stuff that have 0 confirmations in it, which includes the transaction I just sent. So yeah, there's 3. So in the same way, help list unspent. So if you look in here, yeah, min conf is the first option. So I put 0 to say, I believe the default will be 1. So the 0 confirmations includes the mempool. So that's one of those details. Okay, so I've actually gone longer than I intended here, I believe. We're at 8 o'clock. So I might as well, yeah, wrap it there for this presentation.